Finding the derivative. Before calculus, you learn the slope of a line. In calculus, the slope, or rather rate of change, is extremely important for the overall focus and concept of the subject. I'm specifically talking about derivatives. Derivatives are the slope or rate of change at any point on the graph. In calculus, you can learn of the power, product, or quotient rule to help find the derivatives of a function. But I'm not here to tell you of those specifics. I'm here to explain the overall concept of derivatives. Overall, derivatives are the rate of change of a function at a specific point. It is used for nonlinear graphs like these. We use this base formula to help find the derivatives. Looks complicated, doesn't it? Well, it's not once you split it apart. One part should look familiar. It's the slope formula, trying to look all fancy-smancy. With this part of the formula, you want to make sure that you have 2 points. What? It only has one term in the bottom? Change it. Make it look like the slope formula, but keep it the same equation. Change just h to x plus h minus x. Ba-bam! Slope formula complete. But what about the little extra doodad that we haven't looked at yet? Just wait, I'm getting to that. So the very, very important part of this section of the formula is this h, arrow, and 0. So what this little thing is saying is that the limit is as h approaches 0, meaning we look back at the slope part of the formula and see where h is. In the formula, it is usually the first pairing, x plus h, x plus h. We can plug any number in for h, say 3. We can see where the point is on the graph, but h is supposed to approach 0. What does that mean? It means we are going to move that 3 closer to 0. So now it is a 2, then a 1, then a 0.5, then a 0.2, and so on and so forth, until we can see what it will eventually be as x plus 0, with h being replaced by the 0. This allows us to predict what the line will look like at h equals 0. If we did not do it this way and still want to find the derivative or instantaneous slope at a specific point, we could draw an infinite number of lines through that point. We cannot use the regular slope formula because the denominator would equal 0 every single time. Using this method allows us to find the tangent line at a single point. Finding this line allows us to find that line's slope, which is the derivative at the single point on the graph. The standard form of the limit definition will lay the groundwork for the rest of calculus.